application.
Yeah.
Okay, I think we should start. So it's let me introduce you.
Okay.
So it's we are super happy to have Kerry Krutilla today. Kerry is let me read because otherwise I will make a mistake. I won't, especially now that you have to take O'Neill School of Public and Environmental Affairs. So let me say correctly. So it's so Kerry Krutilla is professor of public policy at the O'Neill School of Public and Environmental Affairs. He also the co-director of the policy evaluation at the IU Vietnam Initiative. His research focuses on the economic evaluation of federal regulations, the transaction cost of environmental policy, and the use of distributional accounting formats within cost-benefit analysis. He consults for the World Bank, the US agency, and the International Development, the Environmental Defense Fund, and the governments of Vietnam and Brazil. So we are super happy to have you here today. Kerry will talk about implementing precautionary in benefit cost analysis, the case of deep seabed mining. Super interesting.
It is. Okay, thank you. I really appreciate the invitation to be here, and I look forward to your comments and questions. So anyway, as Gustavo said, this is a project about a method of implementing some precautionary elements into economic evaluation for this particular case of deep seabed mining. And it's somewhat typical, for example, in the climate change area, we also have policy issues that involve really fundamental uncertainties. And so we have to address those, or we should address those within economic evaluation. So just as an overview here, the evaluation of mining lease applications does pose some significant challenges. There are basically two contexts here. There are a number of countries that have seabed resources within their national jurisdictions. And then also in the area of the oceans that are not national jurisdiction, residually, they're controlled by the International Seabed Authority, which was mandated under the United Nations Law of the Sea Treaty. So there's a lot of fundamental uncertainties about the environmental impacts of deep seabed mining. I'll talk about that in a moment. But what we focus on is we focus on the environmental uncertainties, but that's received a lot of attention, a lot of concern from stakeholders, and we think that the economic situation is equally uncertain. Stakeholder opinion is sharply divided about this. So our goal here is to characterize the nature of DSM as my shorthand for deep seabed mining uncertainties, to review the academic literature on investment evaluation in the context of deep uncertainty and irreversible environmental effects, to assess the benefit cost analysis of deep seabed mining that was sponsored by the European Union. I won't have time to talk about that in my opening. And to make some methodology recommendations for the assessment of deep seabed mining lease proposals. So just a little background here. As the terrestrial deposits on land have been mined out, they're less concentrated and more remotely distributed. And so that has caused the mining companies to look at deep seabeds. And they're large and concentrated sources of a variety of minerals on seabeds. And one of the things that interests mining companies about them is that they're commingled. They're occur together. So a deposit can yield multiple minerals. Some of the seabed minerals have high technology applications, computer chips, cell phones, alternative energy sources, lithium-ion batteries. So as the electric car industry has taken off, the industry is kind of projecting rising demand for minerals. So just to show you how it works, let me go back to my first slide. So this is what's called a production support vehicle. It sits on the surface above the mining site. There's something called a riser lift system that goes from the production support vehicle to the seabed floor. Robots, mining robots, are controlled from the production support vehicle, and what's mined on the seabed goes up the riser lift system. It's dewatered. The minerals are shipped by barge to onshore processing facilities, and then water is returned below. There are three types of deposits that have been turned up. One are cobalt-rich crusts on seamounts. They occur from like 800 to 1,200 meters or more. Then there are these so-called seafloor massive sulfides. They occur on sort of mid-ocean ridges and tectonically active zones that have areas of volcanism. And I can go into all the details on this if you're interested. And then there are manganese nodules that lie in the abyssal plains, which is the broad ocean floor that's out of the continental shelf region, and a land type that actually forms the majority of the world's surface. So three different types of deposits, and again, there are a lot of details here I can go into. So what's the current status? Well, international waters, managed by the International Seabed Authority, has approved 30 exploratory leases, and they've drafted a mining code that they would like to finalize later this year. But so far, no exploitation leases or mining have yet occurred on international seabeds. Then we have Pacific Island countries with seabed resources, and that granted 300 exploratory leases. However, the only mining lease that's ever been granted was granted by the country of Papua New Guinea for the mining of seafloor massive sulfides, one of those deposits I showed, and that project failed. The mining company went bankrupt, and Papua New Guinea government was out $150 million. So this shows you some of the risks that are involved. This Nautilus mining company is basically being restructured out of existence. So one attempt so far, and a fairly notable failure. So one of the things we do in this paper is to classify different kinds of uncertainty. And so we have these distinctions of risk versus fundamental uncertainty. Risk is what is generally dealt with in benefit cost classes or a lot of conventional modeling, where it assumes that we know what the model is, but the parameters in this model might be uncertain, and so we vary those parameters in sensitivity analysis or use uncertainty propagation methods like Monte Carlo simulation. Fundamental uncertainty is when we don't maybe even know the structure of the model, we don't know the links between inputs and outputs, we don't know probability distributions, and that's the reality of the impact of deep seabed mining on ecosystems and habitats and deep ocean floors. We know very little about them because it's very costly to get information on deep seabeds. So we have to deal with the fact that the uncertainty is fundamental. Second distinction here is between exogenous and endogenous. And exogenous uncertainty involves uncertain elements that are independent of the mining activity itself, like what will future mineral prices be, what will future costs be, what will be the state of the oceans in 30 years. And the significant thing about exogenous uncertainty is that you can learn about this by waiting. Rather than taking a decision now, you can defer a decision and learn something from waiting. Then we have endogenous uncertainty, which results from the mining activity itself. What will be the environmental impacts of mining? What will be the production and output of mines? And those can only be resolved by taking action, by beginning the activity. Then we have reversible and irreversible effects. And that is impacts that can be reversed, like, let's say, flow pollution that comes out of the IU heating plant has a, PM 2.5 will have a residence time of a certain period of time, and it's repeated period after period. But then we have a possibility of accumulated damages to the environment, which are stock effects, like, for example, what happens to your lungs when you inject cigarette smoke day after day after day for 30 years. And stock effects tend to be irreversible, and in the context of deep ocean environments, we also have the problem of system dynamics. So there's been a lot of literature in the ecology field in the last 20 years about multiple equilibria and dynamically complex systems, and how shocks to those systems run the risk of moving a system from a stable equilibrium out of that equilibrium zone and shifting to another one. Regime shifts. Such a regime shift might be happening right now in the climate system. So rather than a smooth change, we may see a dramatic jump from one equilibrium state to the other. And again, that's concerned with the impactful nature of seabed mining activities on seabed environments. And then closely related, we have observable versus non-observable. The turbidity that's associated with mining operations can be seen and observed and ameliorated, whereas these regime shifts can result from unobservably for a long period of time. And again, I'll use lung cancer as sort of an example of that. So all of these kinds of issues should be dealt with, or we have to think about when we're thinking about modeling in benefit cost analysis. So the conventional approach of the vast majority of studies on the planet are what we call predict then act. And that is, you make forecasts for the future based on some assumptions about parameters. You make scenarios, for example, low, medium, and high cases for population in the year 2100. And then you predict the future, and then based on this prediction, you take actions. And there's some problems with that decision framing. One is we know that all predictions will be wrong. And so the sort of philosophy in the decision science literature these days is to try to be roughly right than precisely wrong, which is, again, what happens with this predictive approach. There tends to be a lack of precautionary element, and there isn't flexibility to respond to new information. And it's a problem when you sink costs that are irreversible. You make an investment decision, and you can't get out of it. Well, then new information unfolds, and you realize maybe I shouldn't have done that. So, as I mentioned before, the modeling issues are that when uncertainty is fundamental, we may not even know what the model really is. So, reviewing the literature, there are a variety of decision framings with precautionary elements. One is safe minimum standards. Another is value of information approaches, real options, adaptive management, and robust decision making. Value of information approaches apply for exogenous uncertainty, and you can wait for information to unfold. You can defer decision, wait, and learn, and make a decision at that point. And the interesting thing about investment decisions like deep seabed mining is that if you don't take them now, you can always take them in the future. That is, the decision is reversible, but the consequences may not be. And that's something that has to be considered. There's a particular approach that's kind of relevant for this context, and that is the assumption that in the future, natural environments will become relatively scarcer compared to produced goods. So the supply of, let's say, natural oceans will be diminished in the future relative to produced goods. And the demand for natural environments will grow up with income. But a key thing here is that natural environments are not very substitutable in consumption, as we economists would say. That is, if we despoil a natural environment and it's irreplaceable, that's a major loss. Whereas natural environments in production tend to be quite substitutable. We might use a mineral from the ocean seabed, we might mine that, or we might develop a mining operation based on the assumption that mineral will be used, and then through substitution in the economy, some other production process doesn't need this mineral. And so the idea here is that you could be making decisions that are irreversible to produce something that really may not have much value given the way the economy evolves. And I want to just give a very nice example of this. This is a 10-year series on the price of cobalt. Cobalt is used in lithium-ion batteries, and as the electric vehicle market has developed, there's been some excitement about, well, the need for cobalt. Cobalt is also produced, 50% of the world's supply comes from the Democratic Republic of Congo, and that's a very unstable country. So you have a limited supply, and the industry says, boy, we're going to have rising demand because of electric vehicles. So this is the price of cobalt over a 10-year period. And the interesting part of this, let's see, how do I get my pointer to work? This point here was a low point. That was in January of 2016. And notice this very sharp rise to here. That's a dramatic, over 4 times price increase based on these trends that I'm just describing. It's going to be needed. Well, then this point here happened when Elon Musk came out with a decision and said he's going to make his electric cars without using cobalt in batteries. And so that's a production change where we're substituting one mineral for something else. And so then here has been the price of cobalt from, this was March of 2018 until the present time. So again, the sort of argument would be, do you really want to take environmental risks to produce cobalt when substitution possibilities might remove it out of the economy completely? So I don't have time, in the limited time available, to really go into these different ways of incorporating precaution in the benefit cost. I will just mention that this last method is a way of generating, let's say, sampling a huge range of possibilities. We would say a very large parameter space to capture all possible outcomes, and then to run effectively simulation experiments, to run models giving different outcomes over 100,000, maybe even 1 million different parameter combinations. And then you use big data to try to pull out from this global sensitivity analysis sort of outcomes that seem important, and to try to identify which parameters in the system are most influential in affecting outcomes. And then you can try to, for example, redesign a project or redesign an adaptive management plan for coastal management and run this policy experiment again. So computerization and big data allows us now to do things with sensitivity analyses that we never could have done before. And we think that this robust decision-making approach has some real advantages in this context. So let me just quickly conclude here that the principle that motivates this paper is that really a searching examination of fundamental uncertainty within the economic evaluation is an important aspect of a precautionary approach to deep seabed mining. Our methodology recommendation is to use BCA with robust decision-making and maybe some of the real options value of information methods. We have an institutional recommendation, which is to require the International Seabed Authority to establish a platform for the routine benefit cost analysis of lease proposals modeled along the lines of the Chilean investment system. In Chile, there's a system in which all investments above a certain size in the country have to be submitted to a system for review. As part of that application, a benefit cost analysis is required. And the Chilean government has spent a lot of time in making it easy to do that benefit cost analysis by developing norms and standards, shadow prices, and so forth that make it relatively easy for the economic evaluation to be done. So we think some research time should be devoted to developing this kind of platform for the ISA, and that mining leases then be submitted into this system for this kind of evaluation before they are granted. So that's basically the summary.
So I'm seeing Luca. Which one?
Okay. So, thank you. Very interesting topic. So I have two questions. One, just a clarification on the methodology.
Yeah.
If I understood well, so you're suggesting that it would be useful to use the methodology that has been developed in economic literature about investment under uncertainty, for example, to study the decision to open a new plant or invest in a new product, adopt this methodology to study these issues. So what would be different here with respect to a normal problem of investment under uncertainty? Is that the fact that the decision can then affect the environment, which can be thought of as a public good, while in the decision of a firm to open a plant or invest in a new product, this is less of a concern? So would this be something that makes this application different from other economic applications?
Well, that's a very good question, and I guess it's really not different in kind, but different in degree.
Okay.
So, reverse here. So, I mean, classic market risk is just a risk about prices. And so that's exogenous uncertainty. What's going to happen to the prices? And so if you are making an investment as a, let's say, in an investment decision that has no environmental consequences, you might be concerned about sinking that investment and then having prices go down. So there's actually a market for financial options that's a way of dealing with that. So if for example, the IU heating plant can go into the options market and buy an option to buy a natural gas contract at a certain price and for a certain amount in the year 2022. And then when 2022 rolls around, if the market price is lower than that negotiated price, they'll just use the market. But if the market price is higher than that, then they'll exercise the option and get the natural gas at that price. So, you know, firms making investments deal with this kind of exogenous risk. And over the short term, there's actually a market for trading risks. So what's different in this case? Well, mining leases are for 20 years, and so there aren't ways of trading, there aren't ways of sort of reallocating risk in this way. And besides this exogenous uncertainty, there are really significant endogenous uncertainties. That is, with the mining at this immature stage, how's the technology going to perform? This hasn't been demonstrated in deep seabed environments. They're effectively adapting terrestrial technology for the seabeds, and it hasn't been demonstrated. So that's an uncertainty that would resolve with some time and experiment. So the technology is much less clear than for a plant on land in some, you know, let's say chemical refining or something. Then So then we have this possibility of irreversible environmental effects, which wouldn't necessarily arise in a conventional investment. And that's closely related to this observable and non-observable. That is, that risks can be emerging that aren't observed until, you might say, it's too late, or until the change has really happened fundamentally. So, regular investments also face some endogenous uncertainty, like learning curve effects, when something becomes commercialized, with production experience, costs tend to drop. So that's an endogenous uncertainty that arises, without, in other contexts than this. But I think the issue is just the scope of the uncertainties that make this a kind of a bigger issue than a conventional investment problem.
Right. If you've got fundamental uncertainty and you don't even really know what the shape of the model is, how big does the parameter space of robust decision making get? It seems as if infinity is well within view. Logistically speaking, are we saying that we're uncertain, but we've got 3 or 4 prime candidates, and that's easily dealt with in the space of robust decision making, or?
That's a really great question. And generally what happens is there are stakeholders that have views on the model and have views on what parameters are relevant. And one of the folks that are proponents of robust decision making, one of their arguments is, so I'm going to go on a tangent here and get back to your point, is that sometimes there are heated debates. In fact, one of the arguments against predict and then act is that people then get into a big controversy about, does global warming exist? Does it not? It becomes politicized. Sometimes with robust decision making, you can find that differences of opinion turn out not to matter that much in terms of the outcomes. And so it has that nice attribute. But getting back to your point, generally a structure is imposed by the knowledge and opinions of the people involved. And so we have
expert elicitation.
It's related to that. You have 30 people who have opinions about the consequences of deep seabed mining. So part of it is expert elicitation. But a structural element beyond that is that they might have different models. They might have, and so there's some debate about the models, and you can use this structure to explore different modeling assumptions.
So your uncertainty is finite, and that makes the robust decision making finite.
I guess that's a fair statement.
Mike.
Kerry, thanks for this presentation on International Seabed Authority. This is not something I've looked at for 10 years, 15 years, maybe 20.
I thought there might be some IR stuff.
Yeah. I'd like to push the international politics aspect
Sure.
of uncertainty and all this. Back then, it was always kind of interesting to look at this regime area because it had this international organization, and yet there was nothing going on yet. There was an international organization set up to govern a market that was then in the future and is apparently still in the future, in the sense that you've only had this one failure, so forth.
That was in coastal waters.
It was in coastal waters. So even there's still a lot of uncertainty.
Mm-hmm.
So is there still a concern with whether, when this actually takes place and these mining operations take place and some multinational corporation has this mineral in their greedy little hands that they pulled out of this global commons, the seabed, that they'll be able to keep the profits that they make from it, or whether there will be, the ISA will find some way for this to finance various sorts of programs, including, very nice meetings in Tahiti and things like that to govern all this. There's a lot of skepticism about whether there will be a lot of extraction from the companies rather than really allowing them to make the money from this risky sort of benefit. So to what extent is that kind of uncertainty still out there, or has that kind of been dealt with these processes that are in place?
You're seriously asking if the political uncertainty has been totally resolved?
Has it been resolved at all? Has it been reduced?
Well, I think there are huge, huge problems.
Mhm.
So the ISA has a dual mandate to extract resources and manage resources on seabeds for the benefit of humanity.
Right.
And to do that in an environmentally sustainable way. So in this draft mining code, they have, how to apply for lease and all that stuff. And then they have environmental management plans, which to their credit, establish set-asides
Okay.
around mining areas, 30 to 50%, and they're invoking scientific expertise in establishing these. I sent an article to Vicky that was by one group that's working on this. In that sense, this is not directly getting at your question, but I will loop back to it. It is somewhat unique in that it is establishing a regulatory framework before an industry is in place, as opposed to having the industry pollute and go do its stuff and then, So it's making that attempt, it's engaging scientific community, and that's all to the good. The thing that I worry about is that its annual budget is something like $9 million. I don't know what the School of Public and Environmental Affairs, the O'Neill School budget is, but I think it's, I don't know, maybe, Bob, do you know?
35.
35. 44. Okay, 4 times larger. Then, and as far as I can tell, it has regulatory competencies that are distributed amongst 5 cabinet agencies in the United States. The Department of State, the Commerce Department, the Department of Interior, EPA, and also the Justice Department Antitrust Division, because it's responsible for managing seabeds to ensure competition and not have one country monopolize. So it has this vast, authority, and there's the question of whether it can do that. In terms of corruption or this sort of thing, I do think that's a concern. The royalty rate, well, first off, the royalty rates that they're talking about are something like 4 to 7%. I haven't really looked into this issue, but that instantly raises a red flag to me about the history of the world involves countries giving away resources for free to multinational corporations. I mean, why is the royalty rate 4 to 7%? But aside from that, just to finally drill in on your point, I'm concerned that countries like China or countries that have parastatal companies will be used as a way of, let's say, they don't care about the economics, so doing a benefit cost analysis, this is why the Lease, the Seabed Authority should do benefit cost analysis. Country like China may be interested in a strategic advantage that can be gained by, getting into this business, and they're willing to take a loss on the mining operation to advance the larger strategic goal. And guess what? China is the first country that looks as if they're going to be involved in the first actual mining operation for manganese nodules in the Pacific Ocean on the abyssal plains. That appears to be coming down the pike. So I think there are a lot of issues, and so the worst case would be, of course, these resources are exploited with very little profit, A, and B, to the extent that there is profit generated, that the ISA might, as you say, use it for, let's say, rent dissipation, rather than actually being returned to countries for their betterment. So, I haven't really researched this issue, but intuitively it seems like a significant challenge.
The point about China is very interesting.
Chef, sorry, Jessica. please.
Yeah, so this was really, really fascinating. I feel like I learned a ton reading this paper. Totally, the ECA analysis is not something I'm really familiar with, actually. But so I have two questions about this. First is, at the beginning of the paper, you say what is needed is I think, an integrated stakeholder approach.
Yeah.
And then I was sort of expecting that we were going to learn about who the stakeholders might be and how they are going to be integrated. And I was curious because you sort of gesture towards cultural and social impacts, but it's not clear to me outside of the sort of expert community who is actually a stakeholder besides the firms and the governments, right, in this. In particular, then how would you parameterize their interests in this space, which I'm not necessarily expecting you would have an answer for off the top of your head, but I'm just curious.
Well, those are really outstanding questions, actually. And first thing is, I do have an updated paper, because between the time I submitted this one and now, I've spent most of my waking hours revising it for submission. So I asked Allison to put up the next iteration. So it's a lot bit clearer, but not on that point. So more work to do.
Okay. It was actually a two-part question. Is that okay?
No, let me deal with the first part.
Okay, sorry.
So the clear stakeholders that have to be included are the mining company and the ISA or the countries getting the lease. Why the mining company? Because the ISA and countries with seabed resources are getting a profit share. And if the mining concern is not financially viable, then there's a problem. And we've seen an example of that with the first, so you really want to do, Asian Development Bank has a format for doing what's called a financial feasibility assessment of infrastructure projects which they co-finance, and that's equivalent of like a massive, credit search on the firm to really establish the viability. So in the case of the Nautilus Mining Company, the company that was involved in this failed project, they were in the business to develop seabed mining. They would have a different risk profile than a larger company that had seabed mining as one part of a diversified portfolio. On the other hand, the risk tolerances for mining companies and those that are leasing these resources are likely to be different, as well as assessments about capital costs. So stakeholder analysis would include both of these, and it would deal with these kinds of differences. So that's first and foremost. In theory, in a stakeholder analysis, you can include other groups. You can include locals. You can, within a benefit cost framework, you can comprehensively characterize as stakeholder all the relevant stakeholders. And if you're interested in this, I can send you some articles I've done on it. But I think that just from a practical point of view, clearly the most important stakeholders are the mining companies and the countries, and then the other stakeholders, such as the local community that might be impacted, they have to at least be talked about, or their concerns have to be addressed, maybe not analytically, but qualitatively or something of that nature.
The second part question just had to do with about this. It has to do with the sort of these four characterizations of uncertainty. I guess one question is, does it suggest that we would be able to largely know if uncertainty was exogenous or endogenous, or reversible or reversible, and I'm not sure that we would, which then leads me to a broader question about how you would do this analysis even in the robustness framework, which is to say, it makes me think of the Scott Page's diversity of models discussion about the extent to which the more diverse number of models you have, the more likely you are to get something that approximates the roughly right, even if precisely wrong outcome. And I was just thinking if, I don't know to what point that is actually part of this literature or not, but it sounded kind of relevant and similar.
Well, again, that's a very interesting question, and actually I'm not familiar with that paper you mentioned, and I'll send you an email. I would love to get it. But I think that it's fairly easy to distinguish between the first two categories, but not so much the last two. That is, I think we can know when we have the information to develop a model and characterize parameter uncertainty with probability distributions. So that's number one. Number two, I also think it's conceptual, so it's not really difficult. I mean, exogenous uncertainties involve environmental conditions that will develop independently of an action. So, we know that, let's say trends in ocean pollution are going to be continuing. Global warming is going to be continuing, whether deep seabed mining happens or not. And to the extent that those things are relevant to the evaluation of deep seabed mining, we have to take into account those trends. Whereas what's endogenous is just simply related to the mining activity itself. So we know questions about technology performance, the whole issue of environmental impacts, they're related to whether we mine or not. So this distinction is conceptual. So I think the first two are fairly clear. The last two are really difficult. And whether something is reversible or irreversible, and particularly whether something's observable or not observable. And I hate to use smoking and cancer as a metaphor, but on a daily basis, smoking doesn't yield an observable impact, and it might never have an impact. But yet, for some people, it might be having a stock damage effect that grows over time, and by the time it's identified, it may be too late to deal with. So that's the metaphor for the, let's say, what's happening now with the emissions of carbon emissions. You can't observe on a daily basis the impact of carbon emissions. By watching this, you don't learn much. So in these cases, you really do need some kind of understanding of the system and some modeling to tell you what's likely going to happen. But then under this deep uncertainty, we have a poor capacity for doing that. So I think these are really difficult, but I think one thing we know, is from the literature on systems dynamics that it's quite possible that deep seabed mining, particularly cumulatively over time, could have irreversible ecosystem repercussions. And that's something we would need to consider, we should consider in the policy making over deep sea mining.
I'm just wondering, I get your logic of expanding the parameter space.
Uh-huh.
That makes a lot of sense because we don't really know, we don't know what we don't know.
Right.
But it seems to me the way you're expanding it here, the left tail gets fatter than the right tail.
Can you explain? I don't understand.
Sure, it's your metaphor is it's like smoking. There's no upside to smoking in terms of lung damage. Either it does nothing or it gives you cancer.
Right.
Okay. And in your logic here, deep sea mining could produce irreversible damage.
Right.
It could, I don't know, uncover Godzilla or something like that. And we're like, who knew?
Mm-hmm.
But there's no right tail. You're not expanding the parameter space on the right-hand tail, where we mine and we find something we never expected, or we find out that, I don't know, there's not just some valuable stuff there, but there's an order of magnitude more good stuff than we thought. I mean, is that just the nature of the problem that as you're seeing it?
Well,
Or is
that's,
it
you
something
know,
that, or would you say that's the way you're describing the problem here?
I would. It's an interesting point. And I really do appreciate the questions that have been asked because they're very thought-provoking. But what I would say is that, you know, one strategy for reducing uncertainty is to explore, do research, produce information, and by producing a different information, you reduce the parameter space. And you do have, you know, mining companies aren't just going out and arbitrarily starting mining activities on the bottom of the sea. They all get exploration contracts.
In the best areas, what they think are the best.
What they think are the best areas. And they explore and they sample, and so they get some estimate of what's there. So I guess what you're suggesting is that this kind of activity could yield what? False negatives?
Well,
Maybe there's something there.
I think I understand your argument a little better. What you're saying is the nature of the exploration is that they're characterizing the right-hand tail fairly, well, relatively speaking, a lot better than the low probability that the things we don't know then are dominated by low probability, really awful outcomes. Whereas we have a pretty good sense of what the good outcomes look like.
Mhm.
And that benefit cost analysis doesn't, you know, well, we've explored and we found out we haven't destroyed the seabed and we haven't seen any Godzillas, so we're okay. I mean, your point is well taken.
Well, I think your point is well taken. Because exploration could yield false negatives, right?
Mm-hmm.
Or maybe, as you said, the areas are being explored that have been self-identified to be promising. Maybe something has been left out that's, you
Well,
know.
they're certainly not going to look for places where their chances of problems are, relatively speaking, high. They're going to search for places that look like they're going to demonstrate the technology. So the risk reduction on the tails is going to be leaning one way.
Yeah, that's right. And
Okay, that
although,
makes sense
although in
to me.
theory, still, I buy your point in theory, but I like your point.
What you're saying is that it's not evil companies trying to not let out that they're despoiling the environment or could be despoiling the environment. They're just exploring, and the fact is,
They are.
because exploring is endogenous, it's going to reduce one kind of risk, but not the other kind of risk.
Yes, it produces information. And by the way, so there are a couple of points to make here. Couple of points to make, and that is the exploration is a socially beneficial activity in the sense that the majority of the information we have on deep seabed environments comes from mining exploration. It's extremely costly to do research on deep seabeds. And so you have exploration teams that include environmental scientists who can study the environment while it's being explored for minerals. So that's a side effect. But, you know, there is some prior, you know, from geology and knowledge about where these mineral resources are going to be. So, for example, the heavy, the seafloor massive sulfides, they occur on tectonic ridges where there's volcanism. And what happens there is that seawater gets under the surface and it gets superheated and absorbs minerals. And then because of thermal properties, it rises to the surface.
Brown smokers?
Brown smokers, that's it. And form these vents. You know, they can be up to 20 meters high. And so then as this superheated water gets into the ocean, it precipitates these minerals in these cones. And some of these vents are active and some of them are inactive. So companies are searching for, first off, these vents are easy to find. the ones that are smoking. So that makes the exploration, relatively easy. The ones that aren't smoking are more difficult to find, and actually, it would be nice to start mining there first, because the active vents have these amazing ecological communities that are based on chemosynthesis, chemosynthesizing bacteria that produce energy from chemistry, and that builds the ecosystem, because nothing organic is precipitating down. So scientists are very interested in these ecological communities. They have some implications, for example, for life on other planets. How could we have life on planets? So there's some interesting dimensions there. But anyway, that's a target zone for this particular type. And then for the manganese nodules, they lie on the surface of abyssal plains, and there are some geological characteristics that, certain formations, just like oil companies will prospect in areas with a certain kind of geology, the prospecting for manganese nodules, will be pretty far away from this volcanism zone and sort of the older areas of the ocean, because it takes millions of years for manganese nodules to form. It's basically the same process as the venting. You have mineral precipitate that adheres to shark's teeth and other things, but it takes millions of years. So where do you search for those? In the oldest area of the ocean seabed. So I guess the probability of a serendipitous discovery of, El Dorado that somehow is missed is pretty low, I think, relative to, let's say, the risks of deep seabed mining.
Scott?
Oh, yeah. This has been great. I've really enjoyed it too, Kerry. In fact, I have a book coming out in a couple months, and one of the chapters is on deep seabed stuff. So I'll send it your way, and I'll
Wonderful.
your thoughts and critiques too. But just in brief, as process in writing that, I talked to the person at the Pew Charitable Trusts, who's kind of doing this whole deep seabed mining project, and he actually participated in drafting the mining code. So if you're not already in touch with them, I'd be happy to connect you guys.
Please do, because I'm trying to figure out who there to kind of make this argument to.
Yeah, and honestly, they're really keen to have academics come to Kingston, and there's worse places to go, particularly in the winter for the next mining code conference. So that could be a fun opportunity to talk to some of these folks. So I'll make that connection. Also, on kind of the boundary limitations here, some of the chapter that I've been working on looks at the continental shelf delimitation processes and basically the failure for low-cost, effective dispute resolution in this context, as these more and more coastal states are trying to grab more and more of this territory, encroaching on what used to be kind of the global commons, right? So the draft of this chapter is what's Selden right, looking at the closed seas argument versus the open seas argument as more and more of this encroachment happens. So I'm wondering if you've kind of brought in that kind of boundary delimitation argument kind of within this framework, because it's a regime, at least, that's under severe financial and political stress right now. They're completely overburdened. So it's just food for thought as part of the overarching kind of common heritage.
So let me ask you, when you say they are overburdened, who are you referring to?
CLCS. So this is basically this committee under the UN Convention on the Law of the Sea, right, that is responsible for deciding continental shelf delimitation claims.
Oh.
Yeah. And they don't have enough funding. There's a backlog of like 20 years worth of cases that they're trying to decide on right now. So defining this line of where territorial seas becomes common heritage and kind of the deep seabed basically is really, it's been a moving target, and partly that's for political reasons. Some countries just don't want them to do that, right?
Sure.
So anyway, that could be, I don't know if you want to go down that road. That might be more of Michael's perspective there, but that could be fun to explore. And the last thing, because I know I don't want to take too long, is this fall we're planning a Governing the Commons 30 years later conference, old commons, new commons stuff, and it'd be really cool to have a kind of a seabed panel or something like that. So we can talk more about that, because it sounds like there might be enough interest even in this room to justify that. So sorry.
Yeah. Well, I'm not a lawyer, and I don't envy.
Believe me, it's a good thing.
I don't envy that panel that is negotiating these boundary disputes between national jurisdictions and the international waters. And when you're talking, I'm thinking, gosh, this reminds me of the history of the settlement of the West and property rights
Oh, for sure.
disputes
Yeah.
and so political economy is just, it's as stable as a universal constant.
I know. That's gonna be part of the ungoverned working group there. Ungoverned spaces. Yeah.
So I don't have much, I mean, the real implication is that I shouldn't say the real implication, the economic implication from my point of view is that countries with domestic resources may have less institutional support than the ISA does, as weak and as understaffed and unfunded as they are.
Yeah.
And Papua New Guinea putting up its own money for a joint venture with this kind of situation is just crazy. Now, I don't know if you know, but the ISA has, under the law of the sea, they have set up a mechanism for joint venturing in international waters. And I'm trying to conceive of how that would work. The ISA seriously would put up money with a mining company to exploit. I mean, nothing like that has moved very far, but it's there in the law of the sea treaty, a mechanism for joint venturing for deep seabed mining.
Exactly. Yeah, some of the proceeds are supposed to go to landlocked developing states, but when you look at the studies, I think only 50 cents or something per capita has gone that way, and it's very nascent, like you said. So. But yeah, I'm sure there's others.
Please, man.
Okay, I have a couple of questions actually, because I know you talked about the struggle of finding models for this, but I really think you have an opportunity if you look at oil and gas, because they've been doing offshore drilling for so long now. I mean, I imagine they've sorted a lot of things out. But I also am noticing another thing too, so this is actually not my field at all, but I'm regarding exogenous and endogenous, that sort of uncertainty that you're trying to frame. I think it's probably a little more complicated than what you've suggested it is. I'm not seeing any definition of what it means in this context, and I think that's missing from your paper. And I probably see that because I'm coming to this like not in this field, so I don't have like assumptions about what that term means. But it seems like those kinds of terms are context, are made relevant by the context. So what's exogenous in this situation might be different, say, when it comes to like looking at the comments like Lynn does in governing the comments, whatever.
Well, I'll take your point that may not be spelled out clearly enough in the paper. I think in this next version it is better spelled out. But again, I think it is really being pretty conceptual. And so, in Lynn's context, maybe an exogenous change would be immigration into a locality that would happen whether or not there's a local management regime being set up or not. Whereas the management regime, the effects of that would be endogenous, it's a function of the decision making. And so I think in most decision contexts, we have larger forces that are impinging, which aren't controllable within the decision making context, and then outcomes and whatnot that depend on the decision making. So I think it's pretty fundamental and general.
That's the thing that you need to probably maybe consider including in your paper is like decision making context. I looked for it in your paper, I didn't see that attached to endogenous or exogenous.
Okay, well,
that is a tiny point, but that matters, especially if outside people are reading your work, which you are hoping for, I assume.
Well, it matters a lot. I think it's a very fundamental distinction, so I'll look at my revised version and see. On your first point, that is a good point, and I have a buddy who is a retired geophysicist who worked for the Hess company for many years, and about the ecosystem effects, I'll have to check with him about that. I'll check with him about technical stuff, like for example, it's not a technically challenging problem for mining company to run a pipe through water to the seabed because they're used to running pipes for a couple of kilometers through soil, through earth. You know, he says, you don't have to worry about anything above the mud line, which is the seafloor. But the ecosystem effects, I mean, he expressed a view that I think is quite common in the mining world, which I don't agree with, which is that the biological productivity of seabeds is very low, particularly abyssal plains, compared with terrestrial systems. And he'll say, Kerry, look at all of the environmental damage that terrestrial mining does. And so he sees this as a pretty low impact, not affecting ecosystem productivity. The counter response to that is that ecosystem productivity doesn't necessarily correlate with species diversity or genetic diversity. And in terms of the terrestrial impacts of land-based mining, it would depend on whether seabed mining is displacing that or in fact just augmenting mining. So the degree to which developing seabeds would displace terrestrial mining as opposed to just continue would be relevant to that argument. But I'll have to check with them about the seabed effects. One thing about oil drilling is that it happens mostly on continental shelves. But that should be worse environmentally, I would think, because continental shelves have a lot of biodiversity. So, very good point. I'll ask him about that.
Great. Do you want to wrap up?
Mm-hmm.
Maybe 1 minute.
Or 30 seconds.
We'll do a slow clap.
Well, thank you for the very stimulating discussion. I really do appreciate it. Very good comments. Yeah.
Thank you.
Thank you very much.
Great work.
You didn't get to ask me a question.
Cool. Thank you. I gotta teach you.